I'm sure. Alright, you only have one word problem today. Good contrast from yesterday. But what we're doing today is graphing absolute value functions. So absolute value functions is the first blank.
Still in the morning.
Not valve.
What is that?
Poor handwriting. Functions. Okay. Our basic setup for these, instead of mx plus b, we have f of x equals absolute value of mx plus b plus c, where m cannot equal 0. Okay, if our slope was 0, then the x would go away and we just have a straight line, and that just messes everything up. Okay, so our slope has to be something besides 0. In this f of x right there, is that multiplication?
Maybe.
No! It's a name. It's not multiplication. It's a name. Okay, so we can replace f of x with y. They mean the same thing. And so when it's like this and you graph it, it looks like an angle or a V. And actually, all three of those look like V's, but you could also have one that is flipped upside down. It looks like an A without a crossbar. Okay, that's another example. This first one is special. It's called the parent function. When you have a parent function, we'll have them for all the different kinds of graphs we learn. They are the simplest version of the graph. So like y equals absolute value of x. No extra numbers, no negatives. It's just absolute value of x. So that's the parent function. And what do you think these, where the v comes down to a point, what do you think that point is called? On that graph it's the origin, but even like over here when it's not there, there's a specific name for it. Huh? Vertex, look at you, right? Because on like triangles or something, those are called vertices. We call them vertex. Okay, so that's a vertex, etc. That's supposed to be an arrow. All the vertexes are either a minimum point or a maximum point of the graph. Now I spelled that way wrong. This is not the best day. Okay. Minimum, maximum. All right. So what do you think these are? Minimums or maximums? Minimums, right? Because it's the bottom of the graph. Okay, so this one over here, that's the maximum. Okay, that's the minimum. So if it's a V, it has a minimum. If it's the upside down, or if it's the A kind of looking thing, then it has a maximum. We can figure out what the vertex is without ever graphing, and that's by using this negative B over M comma C thing. Okay, we take the M, the B, and the C that will be numbers. We take those and we plug them into this, and that'll give us our vertex. I want you to remember that. You will have to use it on your notes. So make it exciting. So we're going to graph these equations when we graph. So let's make our axes. That's plural for axis. Axises. All right. The first thing we're going to want to do is figure out the vertex. So to do that, we need to figure out what our M, our B, and our C are. Because for our vertex, we do negative B over M comma C. Okay, that's what's right above there. So what do I put in for B? Because these match up, so instead of B, I put in the 12. So we'll have negative 12 over, what's the M? 3, good. And then what's our C? C's the number that's hanging off the end. Do we have a number hanging off the end? No, so it's 0. So our C is 0. Just reduce that. So what is our vertex? Negative 4, 0, right? Because negative 12 divided by 3 is negative 4. So we can put a point on our graph there, and that's our vertex. Now for the rest of our points, we are going to make a lovely chart like we did the other day. Okay, so if we put x into our equation, y equals absolute value of 3x plus 12, it'll give us a y, and then we'll have points x, y. Oh, you gotta say it loud.
iPad. Is there
Would you like to say anything to YouTube?
Hola!
Oh gosh. Okay.
Is there not an absolute value sign on these calculators?
We'll get there. We'll get there. Hold on. Yes, there is, but we'll get there. Okay, so we already know that if we plugged in negative 4, it would give us 0. Okay, that was the vertex. We already know that one. Now let's pick another x that I suggest it be somewhere close to that vertex. Negative 7. Sounds good. Negative 7. So if we plug in negative 7 for x, we'll get absolute value 3 times negative 7 plus 12. What's negative 7 times 3? Negative 21 plus 12. So what's negative 21 plus 12? Negative 21 plus 12. You can do it. You got 2 calculators on your desk. Surely you can do it.
Yeah, but you want somebody that uses the absolute values.
Oh, damn it. Negative 9. What's the absolute value of negative 9? 9. So our y is 9. So we have the point negative 7, 9. Some of y'all messed up on your test in that you tried to pull it out of absolute value before you simplified. Okay, you need to simplify all the way down until you have just one number, then pull it out of absolute value. All right, so let's plot the point negative 7, 9 on the graph. So negative 4, negative 5, negative 6, negative 7, and then go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there is our point. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Now, what is special about a V? Huh? Has both negative and positive. The two sides of a V are symmetrical, right? We could fold a V in half and it lays on top of itself. It's like a mirror. So, I don't know that your book necessarily wanted me to tell you at this point, but I feel like y'all can handle it. That as long as you get the vertex in one point, okay, that gives us one side of the graph. Ha! It reflects to the other side. Let me try that line again. But let me show you the way to figure out that you've got it exact. So take that point. This dotted line here, that's the axis of symmetry. It goes through the vertex, okay? It's not part of the graph, but it helps to be able to see it. That's your fold, right? If you were going to fold it, that's the fold. So take the point that you see, count how many spaces it takes to get to the axis of symmetry. So 1, 2, 3, right?
Yeah.
Count that many more the other way. 1, 2, 3. That's where your point goes. And you've got the other side.
Ta-da.
Ta-da! So that point would be what? -1, 9. Ta-da, you've graphed it. So when you've got these are what the first 4 problems on your homework are going to be like. Figure out the vertex first. That tells you where the axis of symmetry is. Get 1 more point, and then just translate that, fold it over to the other side. Okay, when we go to the back of the notes, everybody needs a calculator, so make sure you have one. All right, we're going to put this equation into the calculator. So first of all, go to y equals, because we're going to graph it. That's the most top left button. Y equals. Okay. From there, the next thing you're going to put in is the negative. Then, to get the absolute value, because you can put absolute value in your calculator, press math. Well, you need to practice doing it. Math. Go over to the right one where it says num. And what does number 1 say? ABS. That's for absolute value. So press enter on that. On abs. And it should put bars in your thing. In your, put the 3x plus 4 inside the bars. If you're using one of like the black calculators or something, it may not put the bars in there. It may just say abs with parentheses. That's fine. Okay, so put 3x plus 4 inside the bars or inside the parentheses, and then arrow over to the right so you can get out of the bars and put plus 6. Okay, so your y equals screen should look like this. Handy dandy iPad, right? All right, and then when you graph it, it should look like this. So there's your graph. Why do you think it made the A shape? What part of the equation made it flip over? The negative. Okay, so anytime you have a negative in front, you should know that your graph is going to be the A shape. If it's a positive in front, it'll be the V. Just a little key there. Okay, does anybody need help with the calculator? Like, is yours freaking out and doing something weird? All right. Now, I know that you're like, oh, sweet, I can just graph all of them and then sketch the graph. Oh, we forgot to sketch the graph. Okay, so on your homework, you're going to have to sketch the graph based on what your calculator says. It doesn't have to be perfect. Just look and see where the vertex is about. And then look to see where it crosses the axes about. And then you can make your graph from that. About. Huh? It doesn't have to be exact, but it should. The vertex should be about in the right place. It should be pointing up or down, depending on whatever it is. And then it should cross the axes at about the right place. Okay, doesn't have to be perfect. Now, what was I going to say? I got confused. Oh, so you're going to want to graph everything. That is fine to check yourself, but you need to show me the work. Like when you're supposed to use the table and find the vertex and stuff, you got to show me that work or else I'm not giving you any credit. And then these ones are the worst. Okay, way to be positive, Coach Carter. Do you remember when we had, in chapter 1, we had absolute value equations and we split it into 2 equations in order to solve it?
I remember we did.
Jasmine says yes. That's the first person today to say that. You had to do it on your test. You remember? Uh-huh. Okay, so when we're going to do this problem, and then there's 3 on your homework that are like this. Okay, it's a little tedious. It seems because we get the same result that we would have like doing a table or even just putting it in the calculator. But I want you to see why absolute value is the way it is on the graph. So step 1 is to isolate the variable, or not the variable, isolate the absolute value. That was step 1 that we did in chapter 1 as well. So, sure, as long as you know what it says. So what do we need to move to the other side? the 5, so we're going to subtract it. So we get y minus 5 equals absolute value of x minus 3. Do y'all remember what the next part was?
Baby.
Split into 2 equations. Okay, so we're going to split this thing into 2. The first one is we're counting for when this is positive. So it's for when x minus 3 is greater than or equal to 0. That meaning it's positive. The other one is going to be for when x minus 3 ends up being a negative number. Remember, absolute value, we don't know exactly what's in there because it always just ends up being positive, so we don't know what it started out originally. Okay, so for the when we say it's positive, so we just set it equal to both of them, you just take the absolute value out of absolute value. Okay? And then the other one, the other side, for when it's greater than or equal to 0, just write the left side down how it is. So we've got y minus 5. Then for when x minus 3 is less than or equal to 0, we put a negative in front of the entire left side. So negative times y minus 5. Please make sure you're taking good notes, okay? Because when it comes time in like 6 hours or 23 hours when you're going to do your homework,
Yeah, 23.
okay, make sure you've got good notes so you know what to follow. From here, we're just going to solve these for y so we can graph them, okay? So get this one. We need to move the negative 5 over, so we're going to add it to the other side. So for that one, y will equal x plus 2. Okay, and then the other one, this one takes a little more work. We need to distribute our negative in. So negative y plus 5 equals x minus 3. Okay. Okay, and then let's see, we need to subtract 5. So negative y equals x minus 8. We're doing good. Okay, now how are we going to get rid of that negative? Ty, Holden, y'all have an idea of how we can move that negative to the other side?
Yeah.
Add it. Well, we can't just add a negative. We can multiply by what?
You just told me about that.
Maybe you should not rely on him so much.
Another negative.
Yeah, perfect. Okay, so we're going to multiply both sides by -1. But remember, we're multiplying the entire side, so get parentheses. So we'll have positive y, which is what we wanted. Yes? And then we'll have negative x plus 8 from when we distributed that -1 in. Oh my goodness, my face. Okay, so we have two equations. We have y equals x plus 2 and y equals negative x plus 8. If we graphed both of those are both lines, right? If we graphed both of those, we get one line that has positive slope and one that gets negative. Well, that would make an x. Okay, we don't need an x, right? Absolute value is supposed to be v, huh? X marks the spot. So what's particular about these things is that this one, remember, it only works for when x minus 3 is greater than or equal to 0. So we need to take that x minus 3 greater than or equal to 0. This is our domain. Okay. And we need to get x by itself. So if we add 3 to the other side, we get that y equals x plus 2 only works when x is greater than or equal to 3. All right. So let me go ahead and graph that. Oh, man. No, I don't want it there. Change my mind. I want it over here. Do, 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 do. Do, 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 do.
It's pretty straight. You did a wonderful job.
Mm-hmm. Brown noser. All right. So that equation was y equals x plus 2. So our y-intercept is 2. Do it very lightly to start out with. Okay, I'll show you why. 2, and then our slope was up 1 over 1, because it's just 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Now, when did I say this graph happens? When x is greater than or equal to 3. Right? It was x minus 3 is greater than or equal to 0. We move 3 to the other side. So this graph starts at 3, and then it's everything that is greater than 3. So from here on out. So our graph is only going to be that part. We don't include where x is less than 3. So that is y equals x plus 2 when x is greater than or equal to 3. Now the other one was y equals negative x plus 8. And that one will be for when x is less than or equal to 3. So it's going to be from here backwards. So that graph we start at 8. So 2, 3, 4, 5, 6, 7, 8. There's our starting point. And then we go down 1, over 1, down 1, over 1, down 1, over 1. Do we go past 3? No, our graph is only everything left of 3. That's not perfect, but ta-da! It's beautiful. That's my best explanation of that
Red,
today.
white, and blue.
Oh my gosh.
You call it.
Now that ribbon thing on the side, make fun of me for this too, that doesn't go with this lesson. I don't know why I put that in there. That goes with like 2-7 or something. So you don't need that. It's cool. No worries.
No, you sound like you're making a head start.
Okay, so when you do these, first get the absolute value by itself. That absolute value, what's inside, gives you your domain, because half of it's going to be greater than or equal to 0, other half's going to be negative, or less than or equal to 0. Okay, so for the one that's greater than or equal to 0, just write the equation how you see it, except no absolute value. Okay, so these match, except no absolute value. Now the other one, just put a negative with the non-absolute value side, and then both of them solve for y. All this work is for one problem. You have 3 problems like this.
Yeah, I ain't doing all that work.
There's gotta
Bad
be an
choice.
easier way. Only if Einstein was still alive.
Only if Einstein was so. Understand what's happening. All right, so once you've gotten y equals for both of them, okay, the domain for the first one, graph it for that. Okay, so that's why we got only from 3 on for that one, and then we got from 3 backwards for the other one. All right. Zombies. All right, the last problem, we actually don't have to do any equations or anything. All we're doing is graphing. Okay, so first let's make our graph. Sometimes you'll need like just one quadrant of a graph. Sometimes you'll need all 4. Okay, it just depends. For this one, I already know, so that's why I drew it the way I drew it. It says, suppose you pass the Howe Stadium, talking about the football field, halfway along your trip to school each morning. So the stadium is halfway between your house and school. You walk at a rate of 1 city block per minute. Okay, so our rate is 1 block per 1 minute. That's pretty quick. A pretty quick walker. Okay, it says sketch a graph of your trip to school based on your distance and time from the Howe Stadium. So our reference point, everything that we're going to say is going to be in relation to the football stadium. So when we are at the football stadium, we'll be at our origin because we are 0 minutes and 0 blocks away from the stadium, okay? So that point is the football stadium. I can do this. I can do it. Da, 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 da. Right?
You see Indiana Jones?
I don't know what I was singing. I was just singing. Okay, that's the football stadium. The arrow kind of throws it off. We'll just have the picture. Okay. So, and then we'll make the school over here and your house over here. Okay. So, let's do one half at a time. So, say from the football stadium on the way to school, in 1 minute, how far do you go? 1 block, right? Oh, I forgot to say, these are blocks, and this is time. Okay, so in 1 minute, you go 1 block. So there's a point. So when you've walked for 2 minutes, how far have you gone? 2 blocks, right? 3 minutes, you've gone 3 blocks. 4 minutes, 4 blocks, and so on. So there's the on the way to school part. Now, distance, okay, is always positive. So we're not going to have negative blocks. We're just going to say 1 minute before you got to the stadium, how far away were you from the stadium? 1 block, right? Okay. Sorry, just seeing if you're live. So 2 minutes before you were at the stadium, how far away were you? 2 blocks, 3 minutes, 3 blocks, and so on. So there is your graph. Okay, and it's an absolute value because distance is always positive. Time, we can say the time before and the time after we were at the stadium, but the distance is always positive. You only have 1 word problem like this. And you don't have to write an equation. All you have to do is graph. All right. Let's see, we have like 7 minutes left. With the other classes, I have let them choose a kind of problem on their homework, and I've done it for them. So would you like me, or with them? I've done it with them. So do y'all want to do one of the homework problems together?
Which one is the hardest?
I don't know. It's probably either the word, like the one like this, or one like this. What do you prefer?
The longer one.
One of the long ones? Okay. It'll be on YouTube. It's cool. Okay, so one of the long ones. You want one like this? So let's do number 22. Alright, so we're supposed to graph this by writing 2 linear equations. So before we split it into 2 equations, what do we need to do for step 1? Something. Isolate absolute value. So what do we need to move to the other side? What's the only thing that's not in absolute value? The negative. So how should we move that negative over here? Multiply by -1. I think we already did that once. So we get that negative y equals absolute value of x minus 5. Okay, now we need our 2 equations. You don't have to write those titles out on your homework if you don't want to. Okay, we'll have the one for when x minus 5 is positive. So we just write it how we see it. So negative y equals x minus 5. That's how we see it without absolute value. Then we'll have the one for when the absolute value is negative, and what will that one look like? Huh? Negative times negative y. Very good. And what will the other side be? It's just x minus 5. Good. Remember, I'm doing this with you, not for you, so you got to help me out. So what should I do next? Something. Huh? I couldn't understand what you said. Add 5. We're trying to get y by itself now. So the 5 is in an okay spot. So on this one, what should we do with the negative? Yeah, so multiply by negative 1 again. Remember, you got to multiply the entire side by negative 1, so you got to distribute. So y equals what? Negative x plus 5. Very good. And that is, we'll only graph it for when x is minus 5 is greater than 0. So to make that a little easier, let's get x by itself when x is greater than or equal to 5. So that equation only applies when x is greater than or equal to 5. I'm going to go ahead and graph that. So that one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so for that one, I start out. Remember, do it lightly at first so we can figure out what we need. I start out at 5 for my intercept, and I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Hey, I just hit 5. And I need everything greater than 5, so that's everything to the right. So as I keep going, I get my line. That one's not even close to straight, so don't make fun of me. I see it. Okay, so we got half of it. Let's get the other half. So for the other half, just get this down to y equals, and then that'll be when x is less than or equal to 5. So it'll be everything to the left of 5.